In this video, we are going to be looking at a rule involving tangents and circles. So if you remember, a tangent is a line that just touches a circle once and doesn't cross into the circle, just touches the circumference once and continues going. So here we go. Mr. Foti has a secret about tangents to a circle. Can you figure out what it is? Now on this side here, the red lines are going to be tangent to the circle. On this side here, the red lines are not necessarily tangent to the circle. So right here, we have a red line, and I know from this diagram that it must be tangent to the circle. Why? On this line, or on this circle here, on this side, we have a red line, and now this one right here, we cannot say is exactly tangent to the circle. There's nothing that tells me it is exactly tangent. Now let's look at this side here. We have a red line again, and I know for a fact that this red line is tangent to the circle. So what's happening in common on this side compared to this side? What are some, maybe, things that we're using? Now let's look at this one here. Interesting. This one here does not necessarily mean this red line is tangent to my circle. It may look it, but does not mean it. Here, we have two red lines. Both of them are tangent to the circle. Over here, I have a red line. It is obviously not tangent to the circle because it goes through the circle. Over here, I have another line, red line, and it is not tangent to the circle. How do I know it's not tangent? And here's my last one. And this one here, the red line is tangent to the circle. So, using some definitions that we came up with in our classes before, can you figure out what is my rule and secret about tangents to a circle based on this exploratory? Based on my sides here, where we are tangent, and this side here where the red lines are not necessarily tangent. We cannot tell. So pause your video and write down what you think the secret is. So the secret is, or here's the rule, a tangent to a circle is always perpendicular to the radius at the point of tangency. So if you remember, a point of tangency is the part where the tangent line touches the circle. This means that the radius and a tangent line create a 90-degree angle with one another. So in order for this line to be tangent, if there is a line going to the point of tangency and it makes a perpendicular angle with my tangent, it must be a tangent line. Okay? So right here, if I look at this, I am not sure if this is 90 degrees. There's no 90-degree symbol there. This could be 89 degrees, my radius and my red line. Therefore, this red line is not a tangent. Looking at this one here, well, this one is 90 degrees, but this isn't a point of tangency. A point of tangency has to be on the circumference, and this one here is not on the circumference. I look at this one here, yes, to the point of tangency, or what could be the point of tangency, it is 90 degrees. But my green line is not a radius, therefore this red line is most likely not tangent to my circle. And then this one right here, I look at it, well, there's my problem. This line does not go through the circle, so this is not a radius, therefore this here cannot be tangent. Even if it was 90 degrees, it cannot be tangent because the green line is not a radius or coming from the circle. A diameter would work as well. And that's where all of these fit nicely. And one thing to note is I can even add in and extend one of these so these green lines are a diameter, and that still would make this red line a tangent. So let's look at our first example involving this tangent rule that we just learned. So here we have AB is tangent to the given circle. So I have line AB down here is tangent to the given circle, which has a center of O, or that's the orthocenter. Now we also know that OA is 8, And we know that OB is 17. Now, can we find the length of AB? Well, since we said that AB is tangent to the circle, that must mean OA is going to the point of tangency, because A is at a tangent point. That must mean this must be a right angle. And since that's a right angle, hey, we could use the Pythagorean theorem, where this is C, and we could say this is A and this is B, where C is always my hypotenuse opposite of the right angle. So we're going to write this in here. I'm going to put C squared is equal to A squared plus B squared. Now we're going to rearrange, in this case for B, so I'm going to have B squared is equal to C squared minus A squared. And I continue, I'm going to end up getting 17 squared minus 8 squared. And we continue that, this is still B squared. I'm going to get B squared is equal to 289, and we're going to minus 64. Now I subtract these, I'm going to get 225. And we want B, so I'm going to square root that. And the square root of 225 is 15. So now I know that AB is equal to 15. So in our second example, we have Jimmy is trying to find the exact radius of the circle below. He measured the following distances. He said BC is equal to 3 meters. So I know B to C is equal to 3 meters. He also measured AC is equal to 4 meters. So if I draw a line from A to C, that is a total of 4 meters. He wants to find out what is the radius. So I'm going to draw a radius here. And I'm going to draw a radius, obviously, to my point of tangency. And I'm going to make this a different color. Let's try this red. So I'm making a radius to the point of tangency. Now this is what we're trying to figure out. And now if we have a radius to a tangent line, that's going to make a right angle. So that's one thing to remember when we're doing questions in this unit, is we could always add radiuses. Because radiuses, even in chords and in with these tangent lines, is something we could always calculate. They're like evolved around radiuses or radii. So let's look at this here. We know this is my C, my 4 meters is my C, because it's opposite of my right angle. So I'm going to go C squared is equal to A squared plus B squared. Because now I have a triangle, right angle triangle, I can use Pythagorean theorem. So once again, I'm going to have, and we're trying to find, let's call this A. We're going to say A squared is equal to C squared minus B squared. Continue calculating and plugging things in. I'm going to get 4 squared minus 3 squared. That's going to give me 16 minus 9, which gives me 7. So now A, these are A squared. We want to find the square root of 7. So once again, we have to estimate my roots. So let's look at my benchmarks. So I'm going to do a benchmark over here. We know that 2 squared is equal to 4. And I know that 3 squared is equal to 9. 7 is somewhere in between here. So I look at that. My total out of, it's going to be 5. Remember, we add those out. And 7 minus 4 is 3/5. So it's 2 3/5, which is equal to, so A is equal to 2.6. Now, that's in meters. So we know AB is equal to 2.6 meters. And that's it.